Hello everyone. In this video, we'll try to understand the roles and responsibilities of a data scientist, how machine learning works, and what are the different types of machine learnings which are available. Right. So let's get started. So first, right. So when you want to call yourself as a data scientist, what are the tools and technologies which you should learn? So the very first thing is you should be strong in programming, right? So you can choose either Python or R, one of this, right? And you have to be strong in statistics and the mathematics, right? And of course, you should be very good at the databases. So maybe you can choose any database like MySQL, Postgres, Oracle database, any database, right? And of course, the machine learning is one of the important, the skill for the data scientist. So we should also be good at visualization of the different graphs. Now you should be good at the cloud, right? That we have different cloud, from different vendors like AWS, Google, Microsoft, right? And it is good if you know any of the big data tools like Spark, Hadoop, etc, right? Because why I mentioned big data as one of the skill set for data scientists is because the data is growing day by day, right? So a standalone system cannot handle the humongous amount of data. So that is the reason why I strongly believe, big data is also one of the skill set for the data scientist, right? So when we talk about the responsibilities of the data scientist, right? So he should be the responsible of collecting the good amount, I mean the large amount of data from different sources, right? And transform it into more usable format. So when I say collecting the large amount of data from different sources, what does the sources mean by, right? Source is the place where your data is storing or residing. We have different sources like databases. That's one of the sources where your data is staying, right? The file systems. We have different ERP systems, CRMs, mobile apps, websites, and many more, right? So we have many data sources, and it's our responsible to collect the required data from the different required source, right? And once we collected it, we need to transform it, which means, see, you are collecting data from different sources, right? So the raw data is not ready to use, right? So when I'm collecting data from the source system, we collect the raw data, we extracted the data. So it might not be ready for your to solve your business problem with the data. You have to apply a lot of transformations, right? So when you collect the data from different sources, you may have missing values, right? So there are few other data which is present in ERP, some other data which is present in file system, few other data which is in database. You need to collect all those three different data from different sources, and then you need to merge those, the different files, right? And then you'll be able to solve the problem from the final data, right? This is what I mean by collecting large amount of data and transforming it into the more usable format, right? Now solving the business problems using data, of course, right? So I have a data, right? Now maybe by seeing the data I can understand, maybe with this data we can try to solve this problem. That's one way. The second way is I have a problem. What I need is to solve the problem, I need the data. Here the data is common, right? So the data need to be collected first, and it has to be transformed in a proper way so that I can try to solve my business problem, right? So as we just discussed in our previous slide, one should be a good programmer and he should be strong in data analytics, obviously, right? So when I say solving the business problem where this data analytics will come into the place, right? The solid knowledge on statistic techniques like hypothesis testing, distributions, this we are going to discuss in our further videos. And of course you should be will be using different machine learning techniques to predict the future based on the current data, based on the historical data, right? And of course the last but not least, you need not to be data scientist, any tool you are in, so you should have good communication skills and the presentation skills. Clear? Now the very interesting thing is, why now? I mean, why data science has a boom now? If you see this machine learning algorithms like Bayes theorem, regression, neural networks, which is also called deep learning, these are the widely used, algorithms in machine learning area. If you see Bayes' theorem is somewhere in 17th century, the regression is somewhere in 18th century, right? And the neural network is somewhere in 19th century, 1940, right? But why recently, like past 10, 12 years? Why? You got me? Because comparatively, like maybe if you take 10 years back, the storage is becoming cheap. That is one reason. And the processing speed also becoming cheap day by day. And moreover, now I know how to handle my humongous amount of data. It's because the big data tools are getting mature day by day, right? And moreover, like when you talk about before the cloud, right? So if you want to process, if you want to store or process the data, right, you need some decent amount of hardware which you need to procure. I mean, you need to buy it, install it, configure it. Now once we got the cloud, it's like this, right? So we can immediately buy a server in a fraction of seconds or minutes, configure it, and run your analytics there, right? So that is the reason, one of the reason why the data science is booming now. And now most of the companies, they are showing interest on the open source tools. Like one of the thing which we discussed in the big data tools, Apache Spark, right? One of the widely used open source tool for the data analytics, right? So, and of course the clouds technologies are available and comparatively cheaper, right? So based on this all these parameters, right, so now the data science has a boom because we know how to deal the humongous amount of data. The storage is cheap, processing speed is cheap, right? And the open source technology are emerging, right? And the cloud technology is available for everyone, right? Now we'll try to understand how machine learning works, right? So let's go to the next slide. So if you see here, I have some data. We'll discuss this in some time. Now usually, right, so as we know, right, from our childhood, we used to learn by seeing, sensing the things, maybe the same things multiple times, so that we can identify the things whenever see them again, right? That's how we learn. So let's say the place where I am staying. So for example, right, so I have few types of apples. Maybe the apples that I found in my areas, which is in red and green color, right? And I see them multiple times, right? So that I can say it is apple when I see it. So maybe due to some reason I move to some other place. There the apples might be in a different colors, which I never seen before, right? But still, I'll be able to predict. Most maximum of the time, I'll be able to, predict. Yes, that's an apple. But I never seen an apple with that color. But how can I, guess or predict that would be an apple? Because of the few other parameters, right? Maybe the smell, the look and feel. So this color is not only the parameter where it will decide an apple or not, right? There are a few other parameters, shape, all those things, right? So based on my previous experience, I was able to predict the things that I never seen before, right? In the same way, the machine learning works. Now, if you see this data, so in this data, I want to predict the price. How I predict the price? Based on the area of the house, build-up area, and the type, whether it's a villa, apartment, or individual house, number of bedrooms, number of bathrooms. So based on this, I'll be predicting the price. So I have this data now, right? So now I'll train my machine learning model with this data, right? So whenever I pass new information like a different area, different type of the house, I mean, number of bedrooms and number of bathrooms, then my model will be able to predict, hey, based on these parameters you pass, like area and square feet, types, number of bedroom, bathrooms, from my previous understanding, from my previous learning of the historical data, this would be the price for the given information. This is how the machine learning works. Clear? Now, as we also discussed, we'll also talk about the different types of machine learning, available, right? So the three major things: one is supervised, unsupervised, and the reinforcement learning. So we'll talk about supervised and unsupervised in coming slides. So we'll lightly touch what is reinforcement learning. You guys might have heard about self-driving cars, right? So how self-driving cars learn, right? It will learn based on the mistakes, right? Let's say if it is taking a U-turn, somehow it hit the divider, or it will understand, okay, so when I'm taking a U-turn, I hit the divider. So next time when I'm taking U-turn, maybe check the radius and other parameters, how much steering I should turn, how much pressure I should apply in the brake, all those things it will understand, and it will try to rectify itself by its mistakes, right? So so in our upcoming videos, we'll be more majorly focusing on supervised and unsupervised learning, right? So yeah, so we have supervised and unsupervised learning here. So in supervised, again, I have two different categories. One is regression, the another one is classification. We'll talk about what is regression, right? It looks for a statistical relationship between the variables that may give us an estimation, a prediction of the particular outcome. Now, if you see this data, let me read out the sentence. It looks for a statistical relation between the variables that may give us an estimation for a particular outcome. Here my outcome is price. Now this price is totally related on the other attributes like area, type, number of bathrooms and bedrooms, right? So there should be some relation between this area, type, number of bedrooms, bathrooms to the price, right? That's how my machine learning algorithm will learn. So whenever in future if I pass new area, type, number of bathrooms, bedrooms with the previous relationship, with the previous scene data, with the previously I trained my model with the historical data, based on that it will predict the price. Clear? And if you see this area, type, number of bedrooms, number of bathrooms, we actually call it independent variables. These are independent variables because this area, type, number of bathrooms, bedrooms are not dependent on any of the variables here. But when you see the price, your price is dependent on the bathrooms, number of bedrooms. It also depends on the type and the area. It is in the square feet, whatever, right? So my price is also called a dependent variable because my price is totally dependent on these parameters, all of these attributes, right? So we call it predictor variables, we call it dependent variable, we call it label, right? Now, when you also talk about the regression, which we are just talking about, so actually regression is a continuous variable, right? So this price may be from minus infinity to the plus infinity. Usually it won't be the minus, but just right, it's a continuous value. It can be 1 lakh, 2 lakh, 10 lakhs. It can be 1.1 lakhs, 1.12536 lakhs, right? So this is continuous, value. So we call it regression, like house price prediction. We just see the weather forecasting, stock price prediction. All this comes under the regression problems, right? When you talk about the classification, what is generally classification, right? You are classifying whether this person is good or bad. You are classifying whether this people falls under 95th percentile, 50th percentile, right? So you're classifying right? So it is also a regression technique, but the outcome is not continuous. In case of regression, the outcome is continuous, right? Which is minus infinity to the plus infinity. Where in case of classification, the outcome is finite, right? Let's say whether the customer is a good or bad customer, right? Whether the mail is a spam or not spam. Like we'll have some finite number of classes, right? If you see the classification of animals, we have two different major classes, right? And again, inside the classes we have warm-blooded, cold-blooded, with joined legs, without joining legs. But if you see, we have finite number of classes here, right? We know number of classes, but where in case of regression we don't have finite, it is infinite, correct? Sorry, clear? Now the second type is unsupervised learning. See, in case of supervised, I know what I need to predict. In case of house loan prediction, I know I need to predict the price. I have my label. We just talked about what is label, right? I know what to find for weather forecasting, right? I have a label for it, and label is like what it will be the weather tomorrow, right? And I have a label for the classification. My label here is whether he's a good customer or a bad customer. The another label is whether it's a spam mail or not spam mail. I have a label here. I know what to predict it. But there might be a case where I really don't know what to predict. I have a data, right? I have a historical data, right? Where I don't have any information about the customer, whether the customer is bad or not. With the given data, I should be able to identify, I should be able to segregate or group the data into different categories based on the patterns which is inside the given data. So we call it as unsupervised learning. So the major difference between supervised and unsupervised learning is, for supervised, for given data I'll have the labels, right? For unsupervised learning I don't have any label, right? If I don't have any labels, then we call it unsupervised learning, right? So now I got some customer data, but unfortunately I don't have any label, which is whether this particular customer is good or bad, whatever, right? So now with the clustering, I know, right? So in this case, I know how many groups I need. I need two groups, whether good or bad. So I'll say my clustering algorithms, hey, with this given data, I need two different categories. Now what your clustering will do, it will need two different categories, and by seeing the data, maybe you can manually label it. Okay, so this data which is in this group, he will fall under good category. In the second group, he may fall under bad category, right? So you can also use the clustering or unsupervised learning for labeling your data, as we just discussed, right? So in our upcoming videos, we'll talk about the linear regression, logistic regression, right? So decision trees, random forest, KNN algorithms, right? And we also talk about, so all of these things, whatever the algorithms which I just listed out falls under supervised learning. We'll also talk about a couple of unsupervised learning like k-means, k-mode, right? Few other things in our upcoming videos. Now, the very important thing, the life cycle. When you are a data scientist, what would be your, the day-to-day job? Obviously, right? So if you want to do anything, first you should have something to do, right? So in case of data science, first you should have some problem, right? If you have a problem, then you'll solve it. To solve the problem or to understand the problem, first you should know the business, right? So very first step is I should try to understand my business, my customer's business, right? Whether maybe customer may already know the problem. Even if the customer knows the problem, if customer don't know the problem, first you should understand the business, right? There might be the case, right? So my customer don't know the problem, he'll say, boss, this is the data I have. So maybe just try to find out, what problems I can solve with this data. There are such kind of cases, right? So the usual case will be, boss, this is my problem, this is my data, please solve it, right? So both the cases I should try to understand my business, right? After I understand the business, obviously the next step would be I need to extract the data, I need to collect the data, I need to acquire the data from different sources. If you remember the first point which we discussed in the initial slide, right? And then I need to do the data transformations, right? I need to data might be from different sources. I need to merge it. I need to see if there are any disturbances in the data. If I have any disturbances, I need to clear it. Once everything is done, then it's called EDA. It's exploratory data analysis, right? So here maybe I can also call it the data analytics here, right? Here I'll try to find the insights from the given data. What happened with the given data? What happened till today? For example, with the given data, what is my sales today, right? I have 10 different categories, like the cosmetics and the food items. So on each item, how much sales happened, right? So all this we call it EDA. And who are the customers bought my products, right? So whether the customer is from in the top the metropolitan cities or non-metropolitan cities. So based on the understanding of data, maybe I can focus more on my business. Let's say if my customers are more from the tier 2 cities, right? So then I can give some offers, and maybe I'll take some extra care, to solve the customer problems, right? So this is typically EDA, right? So we'll try to understand what's happened till today, right? So we'll try to understand the data now, and then hypothesis and model selection, right? So we'll come up with some assumptions. So what those assumptions, how it looks like, that we are going to discuss in our further videos. Let's not go into it. And the model selection is nothing but for this given data which algorithm might be best suited, right? So whether you should go for supervised, if it is a supervised, whether it's a regression or classification problem, whether it is an unsupervised, if it is a supervised and unsupervised. Under that we have different machine learning algorithms, which one I should select, all those things, the fine tuning, all those things we'll do it in layer. Once that is done, and then we have to deploy our machine learning model in the production, so that whenever the new data comes, it will start predicting it. And obviously, right, so we have to optimize our the machine learning model which we deployed, right? So let's say I collected the data till today, somewhere around, maybe if I have the data till today, I mean the data might be somewhere around 5 GB, right? Maybe after 1 or 2 months my data will obviously grow, right? So I'll get a new data, right? So the data might be 500 MB, let's say. Now I need to retrain my model with the old data, which is 5 GB data which I already collected, and the new data which is 500 MB, right? So the data is growing, so you have to retrain your machine learning model and some frequent basis, right? Like even weekly basis, monthly basis, quarterly basis. So based on the data, it is getting generated. Clear? So what is the major difference between the data analytics or business intelligence versus the data science, right? So typically, right, so when you talk about data analytics or business intelligence, they usually deal with the structured data. The data will be from the different data warehouses. They'll write a lot of SQL queries, all those things, and they visualize the data. When you talk about the data science, they do the same thing what the BI or data analytics does, but they also deal with unstructured data like JSON, XML, the text data in the websites, right? The logs. So we also deal with the NoSQL databases. We'll discuss what is NoSQL databases later, right? So when it comes to approach, they mainly rely on the traditional statistics and the visualization. But when you talk about the data sciences, they deal with statistics, machine learning, and natural language processing. So many other things, right? So the major focus for BI and the data analytics is what happened yesterday and what happened today. For data scientists, the same thing, what happened yesterday and what's happening today and what is going to happen tomorrow, right? That's a role for data science. So as I said, right, the data scientists, so for BI and data analytics, the data is straightforward. Mostly the data will be either in a file system or data warehouse. But in case of data science, it's not like that. You have different sources wherever data is residing, like NoSQL databases, it will be websites, databases, whatnot, whatever you name it, and it's your responsibility to collect the data from different sources, acquire the data, do the data preparation, I mean the data transformation, and then start your analysis, right? So hope you guys enjoyed this video a lot. So in our upcoming sessions, we'll see the basics of statistics. We'll see how a different machine learning algorithm works. We'll also talk about the Python, how to implement this this machine learning algorithms in the Python. We'll have a quite interesting upcoming videos, so stay tuned. Thanks for watching. Thanks for your time. See you soon. Bye bye.